Okay, we're going to grade this homework, Learning Opportunity 7.8.6 this way. I'm going to put the answers right there, and you pause the video and compare your fill in the blanks with mine. Now if you've paused the video and checked all those, if you got almost all of them or all of them, you don't need to listen to the rest of this. If you missed one or more, or want to understand why you missed what you missed, then hold on for the next part. And we'll just consider each one of these fill in the blanks like one separate problem for when we report the minus number. Sequence B was going up by, I'm going to fold this. Sequence B was increasing by 2 each time. So 1, 3, 5, 7, 9. The rule was given. You double the number and subtract 1. That will give you all of the positive odd integers. Sequence C was 4, 5, 6, so 7 and 8 were obviously the next two. The rule on this one, because it was increasing by 1 each time, would be 1 times n, but then you have to add 3 to make the terms match the rule. In other words, if all you had was 1n, when n is 1, the term would be 1, but we needed 3 more than that in order to get the 4 we were looking for. Sequence D, you weren't given enough information to fill in the blanks, but you were given the rule. And so when n is 2 applies to the second column, you double 2 and you get 4, and add 1 and you get 5. And if you apply that rule to these other values of n, the other positions in the sequence, you'll get 5, 7, 9, and 11 in those blanks. The last one on E was 14 because this sequence was increasing by 3, had a common difference of positive 3, and the rule was 3n minus 1. Because if the common difference is positive 3, you multiply the position by 3, but then when you check that with any n value, you realize you have to take 1 away to make it match the term. Sequence F was increasing by 2 each time, so we have a 2n. And that's why we go from 11 to 13 for that last blank. But when you just double the position value, like if you double when n equals 1, if you double it you get 2, but we needed 5, we needed 3 more than that. That's why the rule is 2n plus 3. The next sequence was not arithmetic, nor geometric, but hopefully you notice that when n is 1 you get 1, when n is 2 you get 4, and so the n values were being squared. And so the rule for this one is just n squared. Even if you didn't realize that, as you moved forward and started to see some of these other rules, you can look at patterns between the different sequences and sort of puzzle that out. The last blank here is 25 because of course 5 squared is 25. Since the rule for sequence G is n squared, if the rule for sequence H is n squared minus 1, you just take 1 away from each term from the above sequence to get 15 and 24 for your last two terms. Similarly, the rule for sequence I is doubling n squared, and so you could double your terms from sequence G to get 32 and 50 as the last two terms in sequence I. On sequence J, we're adding 3 to n squared, so n squared is up here, 9, add 3 to 9. You get 12. If you add 3 to 16, you get 19. If you add 3 to 25, you get 28. The rule is given for sequence K. It's cubing n. 1 cubed is, of course, 1. 2 cubed is 2 times 2 times 2, so that's 8. 3 cubed, 3 times 3 times 3, 27. 4 cubed is 64, and 5 cubed is 125. Sequence L was 2n squared minus 1. Well, sequence I is 2n squared, so if you just subtract 1 from each term, you realize that this should be 7, this should be 17, this should be 1 less than 32, so 31, and finally 49.